So we'll go to question number 7. Huh? All are
Sir.
done. All are done except few. If we can finish today the worksheet, then we start topic 2. Okay,
Okay,
we'll
sir.
go very fast,
Sir,
inshallah.
7B.
7C, 7C, 7C is also there.
Sir.
7C is also there. We did 5, right? 5D we
Yes,
did.
sir.
Now we'll do 7C. Can you read the question, please?
A force of 7.5 Newton towards north and a force of 2.5 Newton from 30° north of east act on B. The mass of B is 750 kg. Sorry, sir. I read the wrong question.
Yeah, I don't see any 50 kg
Sir,
here.
an object B. No,
You
sir.
see,
I read D. Sir, I
yeah,
accidentally read D.
you read from screen. That will be better. Okay,
Okay, sir.
you read
An
from.
object B is on a horizontal surface. Two forces act on B in this horizontal plane. A vector diagram for these forces is shown in scale in figure 7.1.
Okay, so here we have two forces, right?
Yes, sir.
Look, one force. Uh, these forces are not. These forces are not like the previous one you got.
Yes, sir.
Directly you are getting and you are making the parallelogram rule. Here we have two forces working on B, right? Towards B,
Yes, sir.
isn't it?
Yes, sir.
And a vector diagram for these forces is shown to scale in figure 7.1. Here we have 7.5 Newton and 2.5 Newton. Yeah. So these are the force. Now go to the next part, what they are saying you. Ah, can you read here, please?
Yes, sir. A force of 7.5 Newton towards the north and a force of 2.5 Newton from 30° north and east act on B. The mass of B is 750 kg.
Okay, so the mass of B is 750 kg. We just have in our mind that information, it will be coming, and it will any other place we have to do working, we will do working. But now what they are saying us in D, can you read please?
So which one?
D.
On figure 7.1, draw an arrow to show the approximate direction of the resultant of these two forces.
Okay, so on figure 7.1, draw an arrow to show the approximate direction of the resultant of these two forces. So here we do not need to calculate. We do not need to, do everything accurately. Just approximately, we should show the resultant of these two forces, and that one we have to show on figure 7.1. So what we have to do for this? We look what I am doing here. Sufyan, hello
Yes,
Sufyan,
sir.
are you
Yes,
listening to
sir.
us?
Yes, sir.
We are doing a question 7 C we are doing, huh? Question 7C we are doing. Are you seeing the screen?
Yes, sir.
So here we have to show approximately. So what can we do? We will try to apply the rule already we learned. Already we know about parallelogram rule, right? Isn't it, Navid?
Yes, sir.
So we will try to always apply the knowledge we already have, that one. So we will apply here parallelogram rule. How? We will extend it here, this way. And also we can extend it here, this arrow. Is it clear? So the direction is our direction, we maintained it, isn't it?
Yes, sir.
The direction already we got, that one we are maintaining, and we are trying to apply the rule already we know. So here we got our parallelogram rule, right? This this line is a smaller line, right? Isn't it? This line is a smaller line, so we will try to make it a little bit smaller. Look here, how I am making it smaller. Till this much I look. This one is 2.5, right? Huh? Navid,
Yes, sir.
this one is 2.5 and this one is 7.5.
So,
So 7.5 is 3 times than 2.5, isn't it?
yes, sir.
So uh, if we want to make it parallelogram, then we try to make it approximately the length like before. The ratio we should maintain, right? Look
Yes, sir.
here, the length I took here, this length is a little bit bigger, right? But it is not 3 times. I will extend a little bit more. It will be then 3 times. Now it's 3 times. Okay. So if you think that this is your parallelogram will be completed like this from here. They are saying approximately. You do not need to do exact. So it is our approximate direction of resultant, isn't it? Huh? Navid?
Yes, sir.
So it is our approximate direction of resultant. If we apply the parallelogram rule. So our first answer, they are asking us, look, they are asking us to, on figure 7.1, draw an arrow to show the approximate direction of the resultant of these two forces. So resultant we always show with double arrow, right?
Yes, sir.
And we can also label it, label this one as resultant. If you label it as resultant, then it will be more specific. So our this part is done. Okay.
Yes, sir.
Now let's do the rest part of this question. What they are saying. Look, yeah. Can you read this?
Sir, me.
Yeah, please.
Show that the magnitude of the resultant force on B is 6.6 Newton.
Yeah, show that the magnitude of the resultant force on B is 6.6 Newton. Now, here we have to draw the scale diagram. Show that the magnitude of the resultant force on B is 6.6 Newton. So we got there, we got there. You can use the same way, huh? The way I showed it here. You can use the same way. Like with your ruler, you can take 6 centimeter. How much you'll take?
6 centimeters.
6 centimeter. Then uh, 1/3 of 6 centimeter is 2 centimeter, isn't it?
Yes, sir.
And the angle you got there, look, now you need the angle. With your protector, you should maintain the angle. Here you got how much? 30 degree, right?
Yes, sir.
So what will be the angle here in between these two forces? The parallelogram when we are showing, what will be the angle here? Can you guess?
Uh, s- mm, sure. 45.
Hmm. In between the vectors, like not the resultant one. I am saying this one and this one. It is
Oh,
it is
acha,
very
sir.
easy
This one
to
and
find.
this one,
It is
120.
90 plus how much? 90 plus 30, 120, isn't
90
it?
plus 90. Yes, sir.
90
120.
plus 30, 30, 120. Like you know about this one. Uh, in geometry, you learned it. Look,
Yes, sir.
if you uh, if you do here dotted lines, these dotted lines, if you are doing here, huh?
Yes, sir.
Then this part is 90 degree, isn't it? From here to here, it is 90 degree, isn't it?
Yes, sir.
And this 30 degree and this 30 degree are opposite angle, isn't it?
Yes, sir.
So 90 plus 30, it is making 120 degree. Listen, here I am taking long time for doing it, but when you will do exam, like like me, it will come to your brain quickly, isn't
Okay,
it?
sir.
That
Huh.
time it will not take more than 20 seconds. When you will be expert like me or more than me, right?
Okay.
So
Nah, sir.
you don't worry, huh? So here you will draw it, huh? And there is one mistake of mine, that is page setting. Uh, when I made it, maybe somehow it's came down, huh?
Okay.
It should be actually in previous page. Then your page could be saved. Anyway, we see here we have to draw, huh? This one.
Yes, sir.
So use your ruler, please. Now your ruler should be used. Your protector should be used. Yeah, Sufyan also, huh? Sufyan, here you take it 6 centimeter. What I am saying, you do it, please. You learn it. 6 centimeter. Why I am writing? Because
Yes,
Hello, sir.
yeah, yeah, 1
Yes, sir. I'm
centimeter
sorry.
is
আমার বাসায় অনেক গেস্ট আসছে তো স্যার, তাই একটু এরকম ইনঅ্যাক্টিভ হয়ে যাচ্ছে স্যার কিছুক্ষণ
so
পর।
1 centimeter is here. Look here. Here we make it 2 centimeter. Huh? 2 centimeter. 2 centimeter is equivalent to 2.5. Okay.
Yes, sir.
2.5 Newton. Do you agree now?
Yes, sir.
2.5 Newton. So you write it here. Our scale is 2 centimeter equals 2.5 Newton. So we had there 7.5 Newton. That's why you wrote here 6 centimeter. Then
6.
another one was uh, 2.5 Newton only, right?
Hmm.
Another one, this one was 2.5 Newton only. That's why we are taking here this one only 2 centimeter. Okay,
Yes, sir.
and we are maintaining the angle. This angle is 120. How much it is? With your protector, you maintain this angle. Huh?
Huh.
You maintain this angle, then you complete the parallelogram. This one might be more than 2 centimeter. I make it longer a little bit. This one you maintain it with ruler. So now
Okay, sir.
it's okay. Now it's fine. 1, 2, and then
Sir, I drew the 120-degree and 30-degree line.
huh? Why 30
So
degree line again? Here, this angle should be 120 degree. That's it. I showed there it is 90, then there is 30. Okay, then
okay,
total
sir.
120 degree. At 30 degree we used here to get here 30 degree, right?
Yes,
Not
sir.
any more extra 30 degree. Okay, so here is the parallelogram. Okay, now
Okay, sir.
our resultant is this one.
Yes, sir.
So you check out what is the length of this resultant. Navid, you
Hmm.
check out what is the length of this one. How many centimeter is this one? If it is 120 degree, okay. If it is 2 centimeter and it is 6 centimeter, then what is the length of it? Have you got it?
So I'm doing it.
Yeah, do it please.
Sir, it comes 6 centimeter.
Your one
Sorry,
is
resultant.
resultant is coming how much? Yeah.
Sir, resultant I'm doing.
Resultant how many centimeters? 6 centimeter you took one vector, right? This one you took
Sir, yes,
6
sir.
centimeter. This one took 2 centimeter. So it should be smaller than 6 centimeter, of course. Because it's
Yes,
smaller,
sir.
you see.
Sir, it's 5.5 centimeter.
So 5.5 centimeter you multiply with, uh, you see, 2 centimeter is 2.5, right?
Yes, sir.
So 1 centimeter is 1.25.
Yes, sir. So
So
5
5.5
into
means,
1.25.
yes.
125. 6.875.
So it is 6.9, right? And
Yes, sir.
if you observe carefully, then you will see there might be some mistake in your drawing. Like maybe
Okay.
you did any wrong in length or you did any wrong in. for the angle. Okay,
Okay, sir.
that's
Sir,
why
what's the answer?
the answer is given. It should come 6.6.
Oh,
If your range is 6.5 to 6.7, then they will accept it. But if 6.9 is too big.
okay, sir. Oh, sir. So probably the angle. So let me measure
Yeah,
it.
the angle or any length you did mistake. Your one came 5.5. It should come 5.3 or 5.4 like that. 5.3 is better.
Yes, sir.
That will be more closer.
Oh, sir, I did mistake in length.
Yeah. So, what is your length?
Sir, the new one,
Hmm. Yeah. New one. What is your length?
is 5.2
Yeah. Check. Then 5.2
resultant.
is more better. Yeah. 5.2 multiplied 1.25. Check.
5.2 to 1.25. 6.5, sir.
So it's nice. It's accepted value. So we accept
Okay, sir.
6.5 to 6.7. Okay.
Oh,
You try to make it more, accurate as much as possible. Then it will be okay.
yes, sir.
So you got it right. So write all details. Huh? The
Yes, sir.
5.2 multiplied 1.25 equals
5.
6.5 Newton.
5.2. Yes, sir.
Okay, showed. It is proved. Huh? Then approximately it is 6.6, isn't it?
Yes, sir.
Okay, then calculate the magnitude of the acceleration of B produced by the resultant force. So your resultant force is 6.6, right?
Yes, sir.
And your mass is how much? Already you got 750 gram.
Uh, 7. Yes, sir.
750 grams. So you have to convert it to SI unit because your answer is in meter per second square. And your force is in Newton. So 750 gram you have to convert to kg. Then use the formula of force equals mass into acceleration. That formula. Do it.
Force into mass. So, is MA. So 0.75 kg. 6.5 divided by 0.75. So the acceleration is 8.67 meters per second.
8.67.
67.
How?
So it comes. So 6.5 divided by 0.
No. You give 6.6 because the standard value is given in the question already. Look,
Oh, achha.
yeah, show that the magnitude of the resultant force on B is 6.6. So you should use that one. Your one
Oh,
came
okay,
by
sir.
scale diagram. They will give marks on it. This is okay, but when you are doing calculation, you do calculation from the given value.
Okay, sir. 8.8.
Yeah, so the answer should be 8.8 meter per second square. Is it clear?
Yes, sir.
So many things you are learning altogether. Huh?
Yes, sir.
Now, next part. You read next part. What is written there? Yeah, determine. Please read loudly.
Did sir wait? Okay, sir. Let me read it from the screen.
Yeah, screen. Yeah, please.
Determine the angle. Sir, oh, two.
Yeah,
Sorry.
three. Two
Determine
is
the
done.
angle.
Two is done.
Sir.
Three.
Determine the angle between the direction of the acceleration and the direction of 7.5 Newton force.
Determine the angle between the direction of the acceleration and the direction of the 7.5 Newton. So acceleration works towards the direction of resultant force,
Yes, sir.
isn't it? Now you see uh, in your diagram you can find this, right, with the
Yes, sir.
protector. So it is our acceleration direction because it is resultant, and it was our 7.5, isn't it?
Yes, sir.
So they are asking you to find the angle between 7.5 Newton force and the acceleration. So what is the angle? Check.
Uh, so direction of the acceleration is,
Is the direction of the resultant force, because this one
yes,
is
sir.
resultant, right?
Yes, sir.
Resultant force is this. So direction of acceleration is direction of resultant force. This one and the
So,
7.5 Newton. Yeah,
yes,
with
sir.
protector check. What
Okay.
is the angle coming?
So 20 degree.
Yes, it is correct. And
Okay,
if
sir.
and you also write beside it, you write that the range is 17 degree to 21 degree. If someone is getting 70 degree, 17,
Yes,
eh,
sir.
that is also correct. If
Yes, sir.
someone is getting 21 degree, in between, all are
Yes,
correct
sir.
answers. So your answer is a nice one, 20 degree.
Okay, sir.
So how you are feeling? Are you feeling confident?
So, yes, sir.
Okay. Sufyan,
Yes, sir.
Sufyan, are you writing?
Yes, sir.
Are you writing the
Yes,
notes?
sir.
Have you
No,
got
sir.
this angle?
No, sir.
Please try it. Sufyan, if you are not trying,
Yes, sir.
then how can you understand? If you have any
I sir,
question, you
এটার
can ask
মাঝখান
me.
দিয়ে আসছে তো স্যার, so it's hard for me to understand, sir.
So, already Navid got the angle, huh? Between acceleration.
Sir, you can move on. আমি একটু পরে করে ফেলতে পারবো.
Okay, then we have also recording, huh?
Yeah.
And we have also recording. Please go through the recording. 9, huh? 9 we had left E. Question number 9 we have left E. So we are starting E. Can you read it? Yeah,
9.
yeah.
9E.
Read it loudly. We are doing recording. If you read, you should read loudly so that
Yes, sir.
recording
Sir,
is good.
I'm searching for 9.
Yeah,
Sir,
searching for the
the
speed.
velocity vector. Sir, the velocity vector diagram for an aircraft heading due north is shown to scale. In figure 9.1, there is a wind blowing from the north to west.
Northwest, huh?
Yes, sir.
Northwest. So wind blowing from northwest. You see aircraft.
Yes, sir.
Sorry, excuse me. Excuse me. So here we got north aircraft
Yes, sir.
direction. Can you see the diagram?
Yes, sir, I can.
And wind blowing
Wind blowing from north to west.
Yeah, north to west. So from the northwest, huh? Northwest. If your aircraft is north, then where is your west?
Sir, the yeah up. Sir,
This way.
sir,
Huh?
wait.
Here is west.
North.
Huh?
Yes, sir. North. Sir, to the
Here
right.
is west. To the right.
Yes, sir.
Like if it is west, and its right side is north. I told you that. You just
Yes, sir.
you face to west, then your right side is north. So if it is north, then your west is this side. Okay, don't mix up.
Yes, sir.
So there is a wind blowing from the northwest. That means here it is west and here it is north, right? So northwest from there it's coming. That means it's going to the east south, right?
Yes, sir.
It's coming from northwest, but it's going to east
Southeast.
south. This one you have to have in your mind. As if you are saying that time that is going west.
Yes,
Is
sir.
going to southeast, right?
Yes,
Southeast
sir.
corner. So this way you uh, first understand. Then we are going to next part. What is said here in the next part? You see at the bottom. It said the speed of the wind is
It's 36
36
meters per
meter per
second.
second, and the speed of the aircraft is 250 meter per second, isn't it?
Yes, sir.
So it is a big number. To draw a scale diagram, it is a big number, isn't it?
Yes, sir.
Like 8, 10, those you could make so easily, but this one is quite bigger, right? So what can
Yes,
we
sir.
do? We can also do it easily, like 250 divided by 36. If you do it, then check how much is coming. 250 divided by 36.
250 divided by 36 is 6.94.
6.94.
94
Okay, so what is the double of 6.94?
into 2, 13.88.
13.88. So you can
13.89.
take it as 13.9.
Yes,
You
sir.
can take it as 13.9. Then your 1 centimeter is 18 meter per second. Is it clear?
Yes, sir.
1 centimeter is how much?
1 centimeter is
18.
to,
18.
yes, sir. 15.
18. Huh?
Okay, sir.
You write this skill diagram now. I am uh, giving you any information. This is very important, right? So
Yes, sir.
1 centimeter is so if you are seeing
18.
big number, then you shouldn't be worried, huh?
Yes, sir.
18,
18.
yeah, 18. Look here, 36, right?
Yes, sir.
So this 36 will be 2 centimeter.
Yes, sir.
Okay, and this 250 meter per second will be how much? You told me
8. Sir, 13.88.
13.8. I told you to write 13.9, right?
Yes, sir.
So your aircraft uh, speed of the aircraft will be 13.9 centimeter, and your wind should be 2 centimeter only. Is it clear?
Yes, sir.
While you will do the scale diagram, and the angle is uh, is clear to you. How much will be the angle? How much will be the angle? From here we understand how much will be the angle. Like before, huh?
Yes, sir.
Look, how will be the angle between wind and this is wind, right?
Yes, sir. Sir, I have to go to washroom.
Okay, just 1 minute. Okay, then
Sir, I have to do number 2, sir.
okay. So this one, huh?
Okay, sir. Sir, if I miss something, I'll watch the video, sir.
No problem. I am stopping the recording. You come. I'm pausing.